What's up, toppers? OMG, did you hear slappers? Cool. Just leave a comment now and tell me, in whose style am I speaking now? Now don't tell me that I'm copying him, cause he's a legend and no one can copy a legend, right? Anyways, let's start this video. We are gonna do an epic discussion on the ISC 2020 chemistry paper. So let's start. So here's the first question. It's fill in the blanks. In the question we have equivalent conductivity is the conducting power of all the ions furnished by 1 gram equivalent. I hope you know the answer. Gram equivalent. Now stop complaining about my handwriting. I know it's bad. I'm not gonna write everything. Let me just tell you. Question 1, I've read it, of an electrolyte present in a definite volume of the solution. I hope you got that right. Question number 2. Bleaching powder on treatment with ethanol or acetone gives dash. Okay, here was a dash. So bleaching powder on treatment with ethanol and acetone gives us chloroform, and this is an example of haloform reaction. Question number 3. Outer or vital complexes involved. Okay, it's sp3d2 hybridization and our high spin complexes. Now, let me explain this to you. Outer orbital complexes are formed when a weak field ligand attacks the central atom, right? So, the d orbital is used, the s is used, and the p is used. The electrons present here are not paired up because the ligand attacking is a weak field ligand, and hence, all the outer orbitals are used. Since there are a lot of unpaired electrons present in it, it's a high spin complex. I hope you got it now. Zinc oxide is reduced by dash. It's coke. Zinc oxide is reduced by coke at 1673 Kelvin to form zinc. And let's write the reaction. Zinc oxide plus coke will give me zinc plus CO. So it's giving us carbon monoxide. Epical. Next. So here we are having MCQ type question. Let's solve this. And the answer of question number 1 is option 3. Now why 3? You can even put a quick guess over here. We all know that in SCC the number of effective atoms is 1. In BCC type structure it's 2. And in FCC type structure, it's 4. So definitely the packing fraction of SCC is going to be less than that of BCC, and that of BCC is going to be less than that of FCC. So we are going to have an increasing order, which is only found in option 3, right? In option 1, we have haphazard order, same in option 2, same in option 4, but only option 3 is systematic. So it's the correct answer. Next. So now, question number 2. When acetone is treated with Grignard's reagent followed by hydrolysis, the product formed is. So the answer is tertiary alcohol, which is option B. Let me show you the sample reaction where I have acetone and Grignard's reagent, which is a good nucleophile. So a negative charge appears on the alkyl group. The oxygen is more electronegative. The carbon develops a positive charge. This alkyl group attacks the carbon. And we get something like this in the first step. Okay, cool. And after hydrolysis, this group leaves and we get an H over here. So the final product is something like this. This is very clearly a tertiary alcohol. So option B is the right answer. Question number 3. Which of the following electrolytes is least effective in causing flocculation of positively charged ferric hydroxide sol? So flocculation means coagulation. We all know that. And according to School's-Hardy rule, to coagulate a positively charged sol, that electrolyte will be most effective which has more amount of negative charge on it. If we consider the first option, we have FeCN6, which has a charge of 3 minus on it. The second one has a charge of 2 minus. The third one has a charge of 4 minus. Hence, the third one is the most effective. But read the question once again. The question is asking least effective. So option D is the answer, because the charge in the anion in KBr is just 1. So it's least effective in causing coagulation. Epico. Next, on heating an aliphatic primary amine with chloroform and alcoholic potassium hydroxide, the organic compound formed is an. So very easy. The answer is alkyl isocyanide. Okay, this is carbylamine reaction. You all know this. When you treat a primary amine with chloroform and alcoholic KOH, you get this. Cool. Next, match the following. Oh my god, this is super easy. Silicon and phosphorus. We have acetaldehyde, xenon hexafluoride in N-type semiconductors. In physics too, we have read that silicon and phosphorus are N-type semiconductors. So one goes with C. Cool. Iodoform test is shown by acetaldehyde. Okay. Arrhenius equation is frequency factor. Cool. And distorted octahedral structure is shown by xenon hexafluoride. Okay. So these are the correct answers. Epico. Next. Stop complaining. I'm not copying anybody. What is the common name of polymer obtained by the polymerization of caprolactam? Okay, it's nylon 6. This is a memory-based question. I'm sorry for that. Well, this is a memory-based question from polymers. Is it addition polymer or condensation polymer? So it's condensation polymer. Why Zn2 plus ions are colorless while Ni2 plus ions are green and copper ions are blue in color? So you can explain this that Zn2 plus ions have fully filled d orbital, so there is no dd transition and hence it shows no color. Whereas in nickel ion and copper ion there are incompletely filled d orbital, hence the electrons undergo dd transition. While undergoing dd transition, they absorb certain wavelength or certain energy and the complementary color is observed. Cool. The third question, the molar conductivity of NaCl, CH3COO and HCl at infinite dilution is this, and this. Okay. Calculate the molar conductivity for acetic acid at infinite dilution. So this can be solved using the Kohlrausch law, and I've already written a solution so that this Epico video is not extended for a long time. Otherwise you all will get tired, right? So let's look at the solution. This is the solution. The molar conductivity of NaCl is equal to the summation of molar conductivity of Na plus ion and Cl minus ion, and this value is given to be 126.45. In a similar manner, the molar conductivity of sodium acetate is equal to the summation of molar conductivities of the acetate ion and sodium ion, and similarly, the molar conductivity of hydrochloric acid is equal to the molar conductivity of hydrogen plus and Cl minus ion. Now to find out the molar conductivity of acetic acid, we know that it will be equal to the molar conductivity of acetate ion and hydrogen ion. Now you have to manipulate these three equations to bring this equation. Now you all are genius to see that if you subtract 1 and add 2 and 3, the Na plus gets cancelled with Na plus, the Cl minus gets cancelled with the Cl minus, and we are just left with H plus and CH3COO minus, and we just need this, guys. We just need this. So we got what we need, right? Okay, now just look at the values from the question. Just put them. You have your calci with you, and now you get the answer. And don't forget to write the unit. Okay, the unit is cool. So this was the question. The next question is identify the compounds. Okay, let's do this. We have C6H5 COOH. When we give here SOCl2, we get acetyl chloride. Now we react this with NH3. So as a product, we'll have C6H5 CONH2 benzamide. Okay, let's put some Br2 and KOH. This is Hoffman degradation reaction, and we'll get aniline. So what happens is that this thing disappears. Now this will carry out the diazotization reaction. Cool. This is what we get with the diazonium salt. Epico. Next. An element has atomic weight 93 and density 11.5. If the edge length of this unit cell is 300 pm, identify the type of unit cell. Okay, so basically we don't know the value of Z. Now since I have not solved this beforehand, I'll solve this now, and I'll not get to the answer. Even though I remembered the answer, I'll tell you the answer, but I'll not calculate the full thing. So this is the formula. The density is equal to Z into molecular mass upon Avogadro's number into the volume. A is the edge length, which is given. Pretty cool. Okay, length of the unit cell is 300 pm. So we have A as 300 pm. Okay, now 1 pm means 10 to the power minus 12 meters, and that is equal to 10 to the power minus 10 centimeters. So we have 300 into 10 to the power minus 10 centimeters, right? And the density we are having 11.5 gram per centimeter cube. So we can find out the value of Z. We know everything. We know this. We know the molecular mass. Okay, which is 93. We know the Avogadro number, which is equal to 6.023 into 10 to the power 23. And we know the value of A. Z will come out to be 2.01, which is equal to 2. And you all know that the effective number of atoms in a BCC unit cell is 2. I just mentioned that a few moments ago in a question that came in this paper itself. So Z equals to 2 means it's a BCC type cell. Okay, next. Alright, this is another question and I have done this. Calculate the radius of copper atom. The atomic weight of copper is this. It crystallizes in FCC lattice and has density of 8.93 at 298 K. Okay, so we will use the same formula where density is 8.93, that's given. Z is equal to 4 because FCC means Z is 4. Molar mass is given. We know the Na and we have to find the value of A again. So you have your calculator, you find out the value of A, and for FCC the relation between the radius of the unit cell, the radius of the atom and the edge length of the unit cell is this. R is equal to A by 2 root 2. So put the value of A that you get from here and you will get to your answer, which is this. Okay. Next. Complete and balance the, okay, so these are some equations. E4 plus NaOH plus H2O. Okay, this will give you phosphine plus NaH2PO2. And this reaction, copper plus HNO3. Since this is dilute, this will not give you NO2, but this will give you NO plus H2O. Now the balancing is pretty easy. You can do it by yourself. But this equation, balancing this equation is not that easy. So you can remember this 3 and 8. Generally, it's advised to students to remember the balancing of some typical reactions. If you just remember the left hand side, you will get to know the right hand side. And this is pretty easy. You can do this. Let's go. Next. Write the chemical equation for the reaction of glucose with bromine water. So I've already done this. It will oxidize it partially because Br2H2O is a mild oxidizing agent. Write the sweeter ion structure of glycine. So we know that the structure of glycine is NH2 CH2 and COOH. Now, the zwitterion structure is formed when the carboxylic acid group loses its H plus, and the same H plus is gained by this group, amine group, because of its lone pair. So the zwitterion structure is this. If you draw this structure, you will get full marks. Okay. The next question is pretty theory based. How do antiseptics differ from disinfectants? So you all know antiseptics are mild and they can be applied on body parts, whereas disinfectants are strong agents. They are applied on floors, etc. Name a substance that can be used as an antiseptic as well as disinfectant. Well, the NCERT says that it's phenol solution, but according to me, boric acid can also be an answer to this. Next, an alloy of gold and cadmium crystallizes with a cubic structure in which gold atoms occupy the corners. The corner atoms, okay, there are 8 corners in a cubic cell, and the contribution of each corner atom is 1 by 8. So in total we have gold 1 by 8 times 8, which is equal to 1. And about cadmium, it says that cadmium atoms fit into the face centers. So we have 6 faces, so we have 6 electrons at the face centers, but the contribution of each face center electron to the unit cell is half. So we have half times 6, which is equal to 3. So the formula of this alloy is AuCd3. This is the answer. Next. So even these are theory based questions. Ethylamine is soluble in water, whereas aniline is insoluble in water. We all know that in aniline the lone pair electrons on N atom are engaged in resonance, so they are unable to form hydrogen bonding with the water molecules, due to which they are insoluble in water. Stop complaining, I don't have any copy before me which I'm seeing and telling the answer, okay? Mind that, okay? Slap like now if you are liking this session. This is the first video in this channel and I'm a bit nervous. I don't know what will happen after uploading this video. I'll get love or I'll get hate. But I mean, if you like this video, then just comment down below and suggest me how to improve and what to improve, the content or my voice or the quality. Okay, cool. So that was the answer, and the answer of question 2 is pretty same. Okay, the basicity power is determined by the ease of donation of lone pair of electrons, and the lone pair of electrons on nitrogen atom in aniline is involved in resonance, so it's not easily available, right, for donation. But in aliphatic amines like ethylamine, it's readily available. So aliphatic amines are stronger bases than aromatic amines. Full marks. Next, draw the structure of xenon tetrafluoride molecules. So formula is HCF4. School. The steric number is half times 8 plus 4, which is 6. The hybridization hence is sp3d2. The geometry is octahedral. Now the steric number is 6, but there are only 4 bond pairs. This means that the rest 2 are lone pairs, and 4 bond pairs and 2 lone pairs, and sp3d2 hybridization means the shape will be square planar. If you want to draw this, draw a square, Hc at the center, 4 F atoms at the corner, and the 2 lone pairs here. Cool. Next, calculate the EMF and del G for the given cell at 25 degrees Celsius. Now, maybe many of you have got this wrong, because E is asked, not E0. E0 is when you have 1 molar concentration of both the ions, but if you look at the question carefully, you will notice that chromium ion concentration is 0.1 molar and the concentration of Fe2 plus ion is 0.01 molar. So the E cell will not be equal to the E0 cell. So now we just have to apply the Nernst equation, which says that the E cell is equals to the E0 cell minus 0.0592 upon n log of concentration of products upon concentration of reactants that are raised to their respective powers of their stoichiometric ratios, and put all the values. You will get the value of E as 0.261 volt. The G value will be minus NFE. This is the formula for the Gibbs free energy. You have your calculator, put all the values, and you will get the answer. Next, degree of dissociation, right? Okay, so CH3COOH, so apply the Kohlrausch law again, and you will get the lambda naught of CH3COOH as 390.55, and the degree of dissociation alpha value is lambda upon lambda naught. Lambda is given as 39.05 upon 390.55. We get this as 0.099. Next, name an important ore of silver. This is argentite. That's the sulfide ore. We also have horn silver. That's the chloride ore. That's AgCl. Extraction of pure silver from argentite is done with NaCN. I've given the balanced equations. You can go through them. When it reacts with NaCN, it comes up with a precipitation of silver and the soluble complex. The complex reacts with zinc dust again, and now we get pure silver as precipitate, forming another soluble complex of sodium and zinc. Okay, you can note this down by pausing the video. Next, how will you convert the following? So you may have heard about these reactions. The first one is Ullmann reaction, with which halogenated benzene rings can be converted to biphenyl. The second one will happen through the anti-Markovnikov addition. Don't forget this peroxide over here. This is the main thing. If you don't give this peroxide, then this reaction will proceed to the Markovnikov addition, which will give you the Sedzev product as the major product. So in that case, you will be getting 2 bromopropane, but we need 1 bromopropane. So we have to go through the anti-Markovnikov addition, and for that, peroxide is the most important thing. And the third reaction is a very famous reaction. It has been coming in ISC examinations since the last 2 years, and this year ISC maintains it. Chlorobenzene to aniline. This is a very popular reaction. Chlorobenzene plus ammonia plus Cu2O will give us aniline plus Cu2Cl2 and H2O. You know, this is a very popular reaction. You may know this. I mean, you do know this, right? Next, these are 3 AP questions from surface chemistry. These are theory based questions. You can frame your own answers. A beam of light is passed through a colloidal solution. So basically it shows Tyndall effect. Question number 2, an electric current is passed through a colloidal solution. The phenomenon is known as electrophoresis in this case. And number 3 is addition of electrolyte to a colloidal solution will result in coagulation. You can frame your own answers. Next, how will you convert this? Okay, I've written these conversions. The first conversion is benzol chloride to benzaldehyde. This is the Rosenmund reduction reaction, where we reduce acetyl chloride group or acetyl halide group to aldehyde group by addition of hydrogen in presence of PDBSO4 in presence of quinoline. The second reaction is methyl chloride to acetic acid. So this is chain upgradation. From 1 carbon chain we are going to 2 carbon chain by this reagent. This is an epico reaction. You have to remember this. And when we hydrolyze cyanide, we get acetic acid. Okay. The third reaction is acetic acid to methane. Now this is an epic reaction too. If you remember the name of this reaction, just comment down below. Okay. Now, do it now. Now this is an epic question again. This is the best question in the question paper that I feel so far. So we have to decode the question. A ketone A which undergoes iodoform reaction. Now you have to remember the fact that when a ketone undergoes iodoform reaction, it must have a ketomethyl group in it. So the structure is something like this. Okay, and now just put the rest of the things to fulfill the molecular formula. Now we have 4 carbons, 8 hydrogens and 1 oxygen. So this is our A. This is 2-butanol. On reduction, a ketone will definitely give an alcohol. So this is our B. Now B, we are reacting with concentrated H2SO4 at 443 K, which means 170 degrees Celsius. So in this case, we are not gonna get an ether, but we'll get an alkene. The most substituted alkene. This is our C. Now we are adding ozone with this. We are getting ozonide. So this is C. We have a CH3 and an H attached to this C. Now we do hydrolysis with zinc. What we get is this entire thing and this entire thing. Cool. So we get 2 moles of CH3CHO, and this is our E. But the question does not end here. The question asks for the iodoform reaction with compound A. So let's do it. We have 2-butanone. We will react this with NaOH plus I2, and what we get is definitely iodoform first, which is the yellow PPT, the same color of my pen now, Lamau. Then we get this NaI and water. You can definitely balance this equation, noobs. Cool. Next. So this is also an epic question. We have 2 steps over here. In the first step, we are having the rate constant that is equal to this. So you have to use this formula for first order reaction. When the reaction is 50% complete, then out of 100 units of reactants, you have 50 reactants left in the bottom. So it's 100 by 50, that's ln2. So every time you get K equals to 1 by 3 times ln2. For the first 30 minutes, the K1 will be 1 by 30 ln2, and for step 2, the K2 will be 1 by 10 ln2. Now when you divide these two equations, what you get is 3. K2 by K1 is 3. Now this is a derived expression from the Arrhenius equation. ln K2 by K1 is equal to the activation energy by R into 1 by T1 minus 1 by T2. All the values are given to you in the question. What you need to find is this activation energy. Put all the values, use your brain, use your calci, and you will conclude that the answer is this, 43.85 kilojoule per mole. Epic. Next. Now these are theory-based questions from the D block elements, and you can frame your own answers. The first question is: transition metals and their compounds generally exhibit a paramagnetic behavior. Well, this is because their d orbitals are incompletely filled, due to which there are unpaired electrons present there, and this is why they show a paramagnetic behavior. Done. Question number 2. There is an increase in density of elements from titanium to copper. So yes, when we move from left to right across a period in the periodic table, what happens is that the atomic volume or the atomic size decreases, but the atomic mass increases. And how is the density related? Density is directly proportional to the mass, and density is inversely proportional to the volume. When the volume decreases and the mass increases, so obviously density will increase. Lamau. So this is the answer. Question number 3. Potassium dichromate acts as a powerful oxidizing agent in acidic medium. Well, this is because chromium is present at its highest oxidation state, and hence it can go down and decrease its oxidation state, hence getting reduced and oxidizing others. The reaction is this: Cr2O7 2- accepts 6 electrons in acidic medium to get reduced to Cr3+ and water. So that's it. You can frame your own answers and write them. Next. An aqueous solution of non-volatile solute freezes at 272.4 Kelvin while pure water freezes at this. determine the following. Okay, so before this question there was another question, and there was option between two questions. I'm not doing that question because if I include everything in this single video, this epic video is gonna be extended for a long time and nobody will watch the full. So let's do this. Okay, so we are given the freezing point of the solution. So from here we find out the depression in freezing point by subtracting the original freezing point and the given freezing point of the solution, and that comes out to be 0.6 Kelvin. Now we all know this formula, delta TF is equals to Kf into molality. Now putting the values, you can very easily find out the molality of the solution, and this comes out to be 0.3225. The second question asks about the boiling point of solution. To get to the boiling point of solution, you first have to find the elevation of boiling point. The molality is found out just now, it's 0.3225, and the kV value is given in the question. Put this, use your brain, use your calci, and you get to this. But this is not the answer. This is the elevation of boiling point, and we know the boiling point of water is 373 Kelvin. So the boiling point of the solution is found out by adding the elevation to the original boiling point of pure water, and this is the answer. Cool? Question number 3. The lowering of vapor pressure of water. Okay, so we know this formula, that the molar mass of solute is equal to WbMA into P0 upon WA P0 minus P. And this term is exactly what we need to find. That's the lowering of vapor pressure. And you know the relation of molality with Wb, Mb, 1000 and Wa. These are just signs, or these are just conventions. B stands for solute, A stands for solvent, and here the solvent is water, so Wa means weight of water, Ma means molecular weight of water, that is 18, Mb means molar mass of solute, so P0 minus P is equal to Wb upon MbWa into 18, 18 is nothing but the value of Ma, because the molar mass of water is 18 into P0. P0 value is given in the question, that's 23.756. So you can replace this term Wb upon Mb into Wa by molality upon 1000, because we have just found out the value of molality. Just put this, use your brain, use your calci, and you will get to the final answer. Next, a solution containing 1.23 gram of calcium nitrate. So let's just place our data. What have we got here? Wb is the weight of the solute, which is 1.23 grams. Mb is the molar mass of solute, which is 164 gram per mole. Wa is the weight of the solvent, which is water, and that's given as 10 grams. Ma is the molar mass of water, and that's 18 grams. So now we can find the elevation of boiling point. This is equal to the boiling point of the solution minus the original boiling point of water, which is equal to 0.975 degrees C or 0.975 Kelvin. Now these two are same because this is just the difference in temperature, and the difference in temperature in both the Celsius and Kelvin scale is same. So now we use this formula, delta Tb is equals to I times Kb times molality. Put everything, we know everything. I is the Van 't Hoff factor, which is to be calculated in this question, and we get the I value as 2.5. Epico. Next, so these are some UPAC names. The first one is tetraamine copper 2 sulfate. The second one is dichlorido bis ethylene diamine cobalt 2. The third one is potassium tris oxalto aluminate. You can pause this video to note this down if you don't know. Next, with reference to the coordination complex ion, this answer the following. Okay, the UPAC name of this is hexaqua ferrous 2 ion. The second one, oxidation number of the central metal atom is right here, it's 2. Question number 3, how many unpaired electrons are there in the complex ion? So Fe2 plus means the outer configuration is 3-6, and this means that there are 4 unpaired electrons present. So the answer to question number 3 is 4. State the type of hybridization of the complex ion. So as you can see, water is a weak field ligand, hence it can't pair up all the electrons present in the d orbital, or basically in the 3d orbital. So for hybridization, the 4s, the 4p, and the 4d orbitals will be used, due to which the hybridization will be sp3d2. So the hybridization is sp3d2. Next, so these are some chemical equations, right? Chemical equations to illustrate the following named reactions. These are pretty easy, you know how ether is formed using Williamson synthesis. So sodium ethoxide, when reacts with an alkyl halide, it gives out sodium halide and it forms an ether. The second one is esterification reaction, and you all know that when an alcohol reacts with a carboxylic acid in presence of concentrated sulfuric acid, you get an ester and water. The next one is Riemann-Tiemann reaction, or people call it Riemann-Tiemann reaction, whatever do you call it. I don't know that, I call it as Riemann-Tiemann reaction, and that is phenol when reacts with NaOH and CHCl3 or NaOH CCl4 at 65 degrees Celsius. These are the respective products formed. So this is salicylaldehyde and this is salicylic acid. Next, identify the compounds and so this is the last question. Ethanol when reacts with copper, so it's basically it gets oxidized to acetaldehyde, and when acetaldehyde reacts with dilute NaOH, it's aldol condensation, and the product is this. Okay. The next one is phenol when reacts with zinc dust. This is a very popular reaction. ZNO is formed at the end along with benzene. Now when benzene reacts with CH3COCl in presence of anhydrous AlCl3, what happens is that the COCH3 group gets attached to the benzene ring. This is an example of Friedel-Crafts acylation where we use AlCl3. And the name of this product is acetophenone. So with that, we end this video right here. If you want the solutions to the other questions as well, slap like now and leave a comment now. So that's it for today. Thanks a lot for watching. Subscribe now for more epic videos and make sure to leave your comment. Don't forget that, that's very important. Suggest me where to improve the videos. And that's all. Thanks. Goodbye.